Image contrast is an important factor that affects perceived image quality. Images with higher contrast are usually perceived as more realistic and three-dimensional. High dynamic range displays can achieve high contrast, but they are difficult to integrate with VR headsets. Local tone mapping operators can improve local contrast, but their computational cost is too high for VR. In this paper, we present DiCE, dichoptic contrast enhancement, a real-time method that takes advantage of the human visual system's binocular fusion mechanisms to enhance perceived contrast and boost image quality shown on stereo displays and VR headsets. At the heart of our method lies the observation from vision science that when two stimuli of different contrast are presented to each eye, the perceived contrast of the fused image is dominated by the eye with the higher contrast stimulus. In other words, contrast fusion between the eyes can be explained by a winner-take-all strategy. Our method takes advantage of this property to enhance contrast for all kinds of content. But when doing so, care must be taken as too strong an enhancement can lead to uncomfortable levels of rivalry between the eyes. Previous approaches to binocular tone mapping created two maximally different images by adjusting tone mapping parameters in a costly optimization process. This can take from seconds to minutes to complete. DiCE is based on psychophysical models and findings. This leads to a much more consistent and predictable enhancement. In addition, DiCE can process an image pair in milliseconds, making it suitable for VR. We use a different tone curve for each eye. A tone curve is a function that maps the logarithmic luminance of the input image to the logarithmic luminance of the display device. Assigning a steeper slope to one part of the tone curve boosts the contrast in that range. However, this uses up a large proportion of the output dynamic range budget, requiring contrast compression in another part of the input range. The opposite happens for shallow slopes. For stereoscopic VR displays, which can present a different image to each eye and therefore offer a separate dynamic range budget for the two eyes, we can selectively use lower or higher tone curve slopes to improve image contrast. When fused, the images convey more fine detail in shadows and highlights compared to standard tone-mapped images. To control the trade-off between contrast gain and binocular rivalry, we conducted an experiment to establish the main factors that cause rivalry in enhanced images and find the best parameters for our method. We now show the results of our method in a format suitable for cross-fusion. To sum up, our DiCE method enhances the contrast for most content and observers. Compared to previous approaches, our technique consistently enhances contrast. In addition, the tone curves for our method can be pre-computed independent of image content and applied on the fly, minimizing the computational cost.